Okay, good morning everyone. So today I will start with the announcement. If you see the Moodle, I just update a few things. You can check in the weekly schedule. I put the first is the test answers, the online test answers. The exercise, if you want to check exercise, and also additional content for chapter 12. So chapter 12, factors, the introduction, the dot product, cross product, I put into one video that I hope you can watch by this week, okay? Maybe after the midterm. So next week we can have finalizations of chapter 12 and then maybe going to chapter 13 because the chapter 13 is I think very short. I think we can finish by one day. I think we can finish it. So what I put into the content is the introduction of factors like this. Okay? So the 3D space, factors as in definition, I think you also learned before, and this is just more of like a short review in the video. So the factors, magnitude, some property, the unit vector, and then the dot product, okay, how we define the dot product and how do we use it, and some proof, and also the direction of the vectors. We can make the directions with the angle. We call the direction angle and direction of cosine. Projections also within the vectors, and also the cross product. And I think this is one of the computation is a little bit complex because I think it's best to use it in matrix form, the cross product. And then yeah, some proofing, and here some proofing here, and then the cross, okay. And then some property of the cross product, and that's it. It's end with the volume of this what we call the parallel pipe. Okay? So parallel pipe is a volumetric shape that is established because of the parallelogram. Okay? Because we have two parallelogram that is parallel, and then we call it parallel pipe. Okay, now I will start by continuing from here to the line and plane equations for a while, and then after that we can review some parts of chapter 11. Okay. So I will start with the equation of line and planes. Okay. Okay, so line, if we are looking at our 3D space, for example here, if you are going to define these three lines, we have three vectors with red color, blue, and green. So we define the R0, the red one, and we define also the blue R. Okay. So if we are going to define the factor A, so A is also factor from P0 to P, so P0P, we call this is a factor A. Okay. You can write factor as it is, or maybe to be safe, just make an arrow on the top. Okay. So this is a factor A, right? Now, using the definition of both positions, okay, we have both positions, this P0 and P, which is they are also vectors defined from the origin. We can then write down the relation between these three, that R, or so R is equal R0 plus A, okay, from the factor properties. Okay. And then we see the vector V. The vector V is parallel with A, right? And because they are parallels, we can write that A can be written in forms of V with some multiplication of some T. So T is scalar. So we can also write down that R is equal and we call this the vector equation. The vector equation of line L. Line L is the here, line L. So A is a segment from line L, and the vector equations we can define through the R0 and R. Now then let's break down all the components. Okay, so if you see the picture, you see that P0 has the x0, y0, z0, and P has x, y, z. So we can have an equations from these two components. So let me write here. Let me write maybe about here. So if we define vector V with A, B, C, okay. Then we have TB, TA, TB, TC, okay. So from this R, R0 plus TB, R is X, Y, Z, right? R0 is X0, so I will write completely that this is X0 plus dA, Y0 plus dB, and Z0 plus dC. So we can have three equations, so X equal X0 plus dA, Y equal Y0 plus dB, and Z equals Z0 plus dC. And this is what we call, if you remember what we have in the chapter 10, this is also called the parametric. So this is parametric equation of line L through P0. And maybe N parallel to V. Other illustrations to illustrate if you want to change our P in the its scalar value, then we can consider this picture here, which means that we can move this point. Okay. So this is when t equals 0, which means we are having the p 0 only. If we plus, like the one we see from there, then we can plus, right? And this is our vectors. Or if we minus, then this is going to be that direction. So again, let me repeat that the additional content for chapter 12 I have uploaded on the Moodle, but you need to check in the weekly schedule. Okay, in the weekly schedule, I think the same section with the exercise and answer key for the chapter 11 test. So if you want to know like definitions or some basic computation in vectors, you can watch this content, or I think you can just review your vectors in other lesson. I think the definition, the basic one, is still the same. Okay, and then from this parametric, we can rewrite this parametric. For example, if we write from t equal x minus x0 over a, right? And also for the y, we can also write in terms of t, right? Also the same with z. Right? So this is all with the same t, right? So we write on the left. So we can write x minus x0 over a equal y minus y0 over b and z over c. This is what we call the symmetric equation. And this is just the conclusions. Okay, another way to rewrite the line equation is having the what we call the line segment. Okay, so line segment is basically so if we know that the r is r0 plus the p, right? And if the v is r1 minus r0, so r1 is another line, then we can write down the line segments. So this is from r0 plus t, r1 minus r0. Or we could see it's 1 minus t, r0 plus t. This is another way to write. Okay, so we can rewrite the v in terms of another vectors, if you will. So we call it line segments. So that is mostly on lines. So the next is the planes. So in line, remember that you can define line in space by point and directions. Okay? So if you have the directions, you have a point, then you know the vectors, right? You know the vectors. And you can define into line equations. Which means you can derive the parametric equation for line equations, right? But for plane, plane is more, I think, more difficult to describe. But how do we know? Like for example, I drew like a random plane like that. How do we know the direction of the plane? How do we know that? If you are looking at the lines, if we know the directions, for example, we know this, and of course, if we try to use the initial origin, like origin like that, and we have the other one here, right? So we know if we want to describe, like, if this is a vector, like the previous one, the vector A, then if we know this R0 and R1, then we know the vector A, right? We know the direction, we know how to create or how to establish the line equations. But how about the plane? Okay? How do we know the direction of the planes? How do we know the plane is this, or maybe here, or maybe, yeah, how do we know that? Yes, correct. So we need to have a vector that is perpendicular. And what we call the normal vector. And the other vectors, it can be in any direction as long as they are in the plane, and we can connect them to this normal vector, right? It can be here, it can be there, it can be there, right? Okay. Okay. And then after we know the normal vector, and then what? And then what? Yeah, this is, you need to know the dot product. You need to know the dot product. The dot product, let me review. If I have this n, and maybe here is, let's say A, okay. The dot product, A dot n is equal this, right? And if this having a theta over there. But since theta is 90 degree, right? Perpendicular. So we just need to prove that, okay, that this is need to be 0. Okay? Now in a more clear way, I think this is better. So if you have any points in the plane, let's say we want to take this x, y, z, it is P, point P. And let's say this is the point that we want to make the initial point. Okay, so P0 and P, and they are both defined in both two vectors R and R0. Okay, so from this vector we can create the normal vector which is going over there. So by the dot product, this vectors dot with these vectors will be equal to 0. So we can write that the dot product from n dot the R minus R0 is equal 0. Or in this case, n dot R is equal n dot R0. This is what we call the vector equation of plane. And then let's say we have if the normal vector we usually name with a ABC, the value, and then let's say the R is XYZ, and R0 is X0. So ABC dot X minus X0, Y minus Y0, and Z minus Z0 is equal to 0. And then we can simply write A X minus X0 plus B Y minus Y0 and plus C Z minus Z0 equal to 0. Or we'll just take this, and that's the conclusions. Or if you want to solve this, we can write also AX plus BY plus CZ, and or maybe this plus another scalar and then equals 0. If you want to solve the whole constant, this is the linear equation. In XYZ. Okay, and then let me continue a little bit. So here is descriptions for so let me write first maybe here. So two planes are parallel if their normal vectors are parallel. Okay. So if two planes are not parallel, then they will for sure intersect in straight line. An angle between two planes defined as an acute angle between their normal vectors. So if the plane is not parallel, means that if you are taking the planes in any directions, eventually for sure it will intersect. It will intersect between these two planes. It will intersect here. Okay, I will give examples later, maybe next week. When we also reviewing the whole part of the vectors. Okay. So I'm giving all the introductions, the definitions, okay, and later we can have examples. Okay. Now suppose that if we have a plane and we have a point, it can be point, it can be line, it can be anything, okay, above this plane. The question is, how do we calculate the distance? Suppose that this is going to be P1. So P0 is somewhere in this plane. Now we can also take a look at this. me right here. So if you want to calculate the distance, okay, from the plane to P1, okay, so D is distance from P1 to the plane. Let's say the plane is AX plus BY plus CZ plus D equals 0. So to help us understand this problem, we define P0 in any point on the plane, okay, and we define this vector B. We define vector B. Okay. So if let's say P0 is x0, y0, z0, and P1 is x1, y1, and z1, then the vector B is x1 minus x0, y1 minus y0, and z1 minus z0. Okay. Okay, the distance is actually, we can use the projections from the dot product. Okay. What is the projections? So projections, we can write component B onto A, okay, which means that we are going to project B, vector B, onto A, or here is maybe N, not A. Maybe better to use N. Okay. And using the angle theta in between B and N, and using the absolute value to make sure that this is the distance, the positive distance, then this will equal this is actually from the N dot B is N B and then cos theta, right? And then B cos theta is our component, right? Okay. So we project from here through here, okay? And then we solve this, simplify. The N let me describe N, I forgot to describe. N is ABC. N is ABC. So A multiplied with the B is x1 minus x0, okay, plus B y1 minus y0 plus C z1 minus z0, and then absolute value, and then over the magnitude is a squared plus b squared plus c squared. And then we can write the Okay, since the P0 lies in the plane, then we can rewrite the formula. Distance D from P1 to the plane okay. This is equal D So what we need is this component ABC from the N, and then the point for the X1, Y1, and Z1. So that's the distance. Okay, so I think by next week we can finish the 12 and then 13, and then move to chapter 14. Okay, we are having a break. Okay. So first, you can try a couple of questions here. So first, these two questions you can try first. Interval of convergence and the sum of the series. Okay, you can check the first two, the interval of convergence. So every time question is asking the power series about radius, interval, you need to first start with the ratio test. Okay, start with ratio test mostly, and check the convergences. Okay. And this is supposed to be having the radius, some specific value of radius, and then having the interval. Okay. Okay, I think you can check the other questions here. The other two questions. So you can write first and let me explain the question before. Okay, if you would like to know the first two questions, so let me just give some brief explanations on these two. So right here. Okay, so first is start with ratio test. what is ratio test? You simply take the ratio between the terms that is after and compare with the term an, right? And suppose that an from this series is 3 with power of n, x power n, and then n plus 1 squared, that is the an, right? So then by the ratio test, or if you would like to directly write, you can directly write with terms of limit with n going to infinity, and then we exchange all the n with n plus 1. So this will be n plus 2, right? And then multiply n plus 1. So you can see that we can cancel this out. This will be 3. This will be x, right? So we could move out the 3x. So 3x we can move out, and then limit is n plus 1, n plus 2 squared, right? And by limit, we know for sure that this will be equal to 1, right? So we have the 3x, and we need to state that this will be converged if is less than 1, right? So then we get negative over 3 x 1 over 3, right? But then we need to check, okay? So we haven't really solved it. So check. First is when x is equal 1 over 3. So we get the series. So check when x is 1 over 3. So this will be 1. And then this will be n plus 1 squared. You can use the comparison, and then using the p series. So comparison and p series. So we know that this will be converged, right? And then check when x is equal negative 1 over 3. So this will be negative 1 power of n over n plus 1 over with power 2. And then we can also check, I think definitely we go to alternating series. Check the limit is 0 and it is decreasing, and we know that this is also converges. So this will be B, right? Okay. That's for the first one, okay? The second one, we have the sum, and we have some series inside. Now for this type of questions, you need some knowledge on some basic Maclaurin series, which are the trigonometric, sine, cosine, the tangent inverse, the ln, and 1 over 1 minus x. Okay? So from here, if you remember that this is going to be, if you cos x is is that, right? And if we look at the series given, we can simplify this. And then we can turn this back into the functions that this is cosine pi over 6, which is also e. Right? So sometimes perhaps it's necessary to know the basic Maclaurin series. Okay? Okay, now try these two questions. I think for this type of questions, number 3, perhaps you get confused on the terms. Okay? So let me rephrase. I think this is also the same type of questions like last week, right? So remember that the Maclaurin series is described in sum, and then we call this is the fn0, which means the derivative of the functions, right? And it's n factorial, right? And then this is x with power of n, right? This is the basis of the Maclaurin series. We call this part here the Cn, or the coefficient, right? Because when we derive, or when we break down this into the series, we get the constant plus here, the f, right? And x with power of n, and then plus the f, second derivative, x squared, third derivative, cube, right? And then so on and so forth. Now, we have the functions, that is e with power of x cubed, right? So, when we have this, the first thing that need to be written is we are going to define first what is the functions, okay, in terms of series. Okay. Now, the best way to do it is remember that we have the e power of x as our basis of Maclaurin. So we can write first that this is going to be that this is x with power of n. Right? So basically, if you want to describe the e with power, x cubed, then we are going to substitute x with x cubed. Okay. So let's do that. So substitute. So this becomes x with power of 3n and n factorial. Okay. Okay. Now look at the questions. The question is asking. This is the part of the coefficient, which is this one, right? So when n is 3n, okay? Now we get this is when x 3n, we have this 1 over n factorial. Okay? Let me write maybe to get you more. Maybe let me erase first. This one, okay? So this is also coefficient of what? Of x 3n. Okay, so when n is equal to 3n, we can know that f3n 3n factorial x3n. Okay, and this is also coefficient of x3n, right? So then we know that this 3n factorial is equal 1 over n factorial. So the f3n at 0 is 3n factorial over n factorial. Okay. So D, right? How about the last one? The Maclaurin of the integrations tangent inverse over t. So basically, first we are going to describe the tangent inverse in series, okay? And then define with dp, which means you can also, if you remember the tangent inverse x, divided by x, right? And then you get the series, and then you integrate the series. Okay? So the purpose why the series is useful is because if we get like this type of integrations, if we convert to series first and then the integration, the series, it will be easier, okay, rather than integration directly. Okay? So you could take tangent inverse x. This is 2n plus 1, x 2n plus 1. Okay. And then divide by x to get the same structure with the questions. So this will be just x with power of 2n. Okay. And then integrate. So basically we are going to integrate the x, come to n plus 1. And then we have the 2n plus 1 multiplied with 2n plus 1 is squared. Okay. So I think we can stop here. Okay, then this will be the answer. Okay. You get equal to this when it's x 203. And 203 equal to this. Okay. Okay. Okay, do I have more? Let me prepare another question for you. let me set up another questions. See if you can get the correct answer. Okay. So if, I think similar type. Okay. Just for practice. And then maybe the other question is about chapter 10. I forgot to put inside here the area of region that lies inside both curves R 3 sine theta and R 1 plus sine theta. Don't forget chapter 10. It will be included tomorrow. But more on chapter 11. But chapter 10 still on tomorrow's test. Okay, I think the first one, we can start since it's the same function that like before. So we can start with the e power of x that is equal right? We have the x with power of n over n squared over n factorial, and then we need to multiply with x, right? So then we have okay. Now the question is asking when the f derive 100 times, right? So the n is 100. So we need to make the power here become 100. So we need n equal 99, right? So we need n equal 99. So the total is 100. Okay. So this will be equal to. So when n 99, then we get the x 100, and then 1 over 99 factorial, right? And then remember that this is the coefficient, right? So coefficient in Maclaurin, let me write the basis. This is the Maclaurin. Okay, we always start from here. Okay, if you are confused how to get into the answer, always write or always went back to the Maclaurin basis. Okay, this is the basis for Maclaurin. Okay, and then this is the coefficient. So it's asking the coefficient when n is equal 100. So f 100. This is 100 factorial, and this is when n is 100. We know that from our calculation it's 1 over 99 factorial. So this is equal to 1 over 99 factorial. So the f 100 is 100 factorial over 99 factorial, which is 100. Okay, the second question, maybe I will not completely finish this part, but we can start by maybe drawing first, or take the intersections first and solve the equation so you know which angle you are going to observe. Okay, so you can take the intersection between these two. Between polar curves. So we can start from equaling 3 sine theta and 1 plus sine theta. And you get that the sine theta is equal to 1 over 2, right? Which means that this is going to be the theta that we are looking for is on the pi over 6, or its repetitions, or sine positive in second quadrant, which means that this is going to be 5 pi over 6 with its repetitions. Okay. Okay. And then we can draw and then let's say the 1 plus sine is going to be up here, right? So this will be 2. This will be 2. This will be 0. And this will be around maybe here. Sorry. Okay. So we are looking for, and then we know this is 5 over 6, right? And this is 5 over 6 pi. So it needs to be region inside both curves. So I think this one, right? And then this is a symmetry, so you could maybe just evaluate the half of it and then multiply by 2. Okay. And then remember that when we deal with this area, we can like slice the polar area according to the sector of the circle. Okay. For example, we can start by maybe taking this, okay, taking this line, and then we can have this 2 area that we are looking at. And then we can evaluate. The first one is from 0 to pi over 6, right? Maybe let me write here. Half the r is the green one. The green one is what? 3 sine, right? 3 sine theta squared. And then this one is from pi over 6 to pi over 2, half 1 plus sine theta squared d theta. So you need to plus this 2 and then multiply by 2. Okay, and that's it. Or if you want to multiply 1 by 1, all the area, I think, okay. So this one multiply with this and multiply with this. So in 3 integrations. Okay. Or just 2 and then multiply by 2. I think should be okay. Okay, that's it. That's it for today's.
What's the answer for this one?
Supposed to be 5 over 4 pi. 5 over 4 pi. But I think you can check the answer, okay? And to solve this trigonometry, when you have this square, don't forget to take the double angle. Take double angle formula. Okay, I think I will just end up here. No feedback questions. Okay. I prepared, but I think I will skip that. Can focus for tomorrow.